This is Andy Revkin doing my sustain what thing, where I try to use conversations to foster sustainable outcomes facing complexity and big risks. And people think of me as a climate journalist, mostly through 40 years of doing that, but I have covered all too many earthquakes and the efforts to build preparedness for them, starting before the tsunami in the Indian Ocean. I've been doing this at the times. But we had this recent example off the California coast and along the California coast of a warning that was ended, and that created a flurry of confusion, as these things often do. And same thing goes for tornado warnings and flash flood warnings. If it doesn't actually hit you, sometimes people say, well, what the hell was that about? So my main goal here is to get Dave Snider, who's at the National Tsunami and Warning and Notification System. He's you're an outreach coordinator, I think. We'll talk about your title and your work. To just give a brief rundown on this particular event, and more important, really, what it represents going forward. You know, if you're in a coastal community or even inland where you can be at tsunami risk and or earthquake risk, of course, how do you handle warnings? How do you know what to do? And why it's important to not disengage and go, oh, this is all hooey, just because something didn't happen. So, Dave, again, you've probably been very busy the last few days in the aftermath of this particular event. To just describe a little bit what you do on a day-to-day basis, and you're in Alaska.
That's right. Yeah, it's still dark and snowy as we speak here. So there's two modes of me, I guess. There's event mode and there's non-event mode. They're both probably pretty important, but they have very different characteristics and behaviors, right? In between, our main goal is to help people find information, understand their risk where they are or wherever they go, and start to think about what are you going to do when that moment arrives, when you get the alert on your phone or whatever notification system you've got set up through your apps or your NOAA weather radio, however that arrives at your doorstep. Understanding what you're going to do in that next moment is the conversation that we're having. And that goes at the community level, that supports all the other agencies that are involved in that process, from the state, federal, local communities, Coast Guard, harbor masters, you name it. We want everybody at the coast to have the best, most useful information and make sure that they're working toward a better solution every day. But then there's event mode, and the event mode turns into helping people understand what is happening right now so that they have the best decision-making tools to serve their communities at the level that they're designed to serve. And we operate at a higher national level, but we're kind of that forcing mechanism that gets the process moving and supports all of those local decisions there. So it's definitely an interesting switch, and we've kind of been moving back and forth between that over the last week.
Yeah, for sure. And there's lots of questions about how this plays out. I assume along with the general public, including through media, there are emergency management coordinators and the like in every town and city, and they have to be consistent. Or ideally, you want consistency in what's being said. Same thing with elected officials, who sometimes, even after 9/11, when I was covering that in New York City, there was a lot of inconsistency. The smoke and dust, it's okay, etc. And so it's a big challenge you have with all these layers.
Absolutely. And, one of the natural, probably human social things to do after an event, after you've been upset, especially in an event, is to start saying, well, this didn't work, gosh, if they'd only done this, and this. I would encourage folks, as we're having this conversation today with you and any other conversations that they're involved in, think about what is it that we need to do a better job? What is the requirement that you need from us or from the other agencies that are serving you to do that better job? And let's have that discussion, because we are in a wonderful state of change now within the National Weather Service and the Tsunami Warning System to really put some microscope level improvements on those types of requirements. So bring them forward, make them constructive, and let's go.
Okay, well, let's I'm going to get back to that slide in a minute. This is on a grand scale. I think we have a real problem with our the challenge, I'll say, with communicating risk, where these big events are rare, right? And As Roger Billum, seismologist, had done this data showing there was this long gap when we built a whole bunch of modern society, whether in Portland or Seattle or San Francisco or across the Pacific, in a time when there weren't these big gongs ringing. And the ones that happened were in Chile or way up in Alaska, which was devastating, but not not in the foreground. So you have this gap in our mental state, and that's at the wide scale, the long scale. We'll get back to that. So I want to get to this particular event. So where were you when this took place, and what happens at that moment? Whether it's this earthquake or any other.
Well, in those first few minutes, I'll start with saying we always have staff here at the National Tsunami Warning Center, as does the Pacific Tsunami Warning Center. We're always ready to go, analyzing every seismic signal that's coming in and creating some type of notification that requires further human analysis. And there's a lot going on here that doesn't meet that alerting threshold ever. And sometimes it allows us to send out a no threat message, the Tsunami Information Statement, which is probably what is more broadly known across coastal communities than any alert level. Those are pretty rare. So in that first few minutes, we are analyzing the earthquake, determining its size and its location, and getting a message out within 5 minutes to let coastal communities know, is this a big deal or not? And in this case, it was. And in that next moment, after we are coordinating that message with all of our service partners across the U.S. West Coast and Canada, we're making sure they've got the information, and we're calling in additional staff to support a larger event response. And so I was activated, as well as the rest of my team. We showed up and started looking for confirmation that a wave exists. And that's really the next important step. Is we know an earthquake has occurred. A large planetary event is underway. What we don't know is if a tsunami wave is actually occurring at this point. And that's a really, really important question for all of the next steps. In that next 20 to 30 minutes or so, we're getting information from our seismic partners. Remember, we're water focused here. We're alert level focused on a tsunami water level problem. We use seismic information to get that process started. And so we rely on the USGS and their experts to help us understand how did the earth move in that earthquake event. And that information becomes available in about 20 minutes or so. And at that point, we confirmed that strike slip motion was what occurred with the earthquake. It was not a thrust event or that upward push of land moving the ocean water. And so that was great news.
But and just before you go ahead, another possibility would have been a landslide, right? Which could also generate earthquake.
Exactly where I was going. And so that is why when, in that moment of confirming that we did not have a significant upward thrust motion of the earthquake, why on earth did we keep the warning up for at least another 30 minutes? Well, that's exactly why, because earthquakes cause subsequent problems, and nearshore landslides are one of the big ones. And so we're holding on to that warning just to make sure there's no local impacts from underwater landslides that will affect the California coastline. And the only way to know that is to wait.
That's so interesting. It's that's kind of, I'm sure it's frustrating, but it's the dynamics of the ocean, the seabed, right? It's just the reality.
It's the science that we have. Yeah, it's horribly frustrating, and we want nothing more than in that 6th minute, after we've passed that 5-minute threshold of issuing the warning, to start working on reducing the number of people into the alert or just canceling the alert outright. And so we're working into that process immediately as the next step. Is how do we remove this alert? And looking for information that supports that.
And one of the challenges, I assume, is that every earthquake is different. You can't model this in advance, really.
Well, there is some level that we can do some advanced modeling, and that is why we have these procedures set up in place to know, if large earthquake happens here in this location next to the coast within this distance range, what do we do? And that is what we do in that first message. However, in those next few steps, we are waiting to get more information to enact more on-the-fly modeling there. And that requires the use of the deep ocean assessment and reporting of tsunami buoys, the DART buoys that ring the Ring of Fire and are just off the coast of California all the way up to Alaska and beyond.
Right. I'll go back to that slide here. And that's a significant investment. I think that got substantially boosted after the Indian Ocean tsunami.
Yes, that's correct.
That network. it's really important. The little buoy that could essentially having those out there, and what they're doing is registering not just ocean motion but the seabed dynamics too.
Right, right. There's really only three ways that we can observe something that's related to tsunami. The seismic signals, of course, would be the first part of that. The next thing we can do is confirm that a wave exists with the dart buoy, and really the mechanics of that technology are at the ocean floor. We're measuring bottom pressure, or the amount of ocean on top of that. It's the same idea as a atmospheric barometer for weather, right? We're measuring the amount of air with a barometer. The bottom pressure recorder is measuring the amount of ocean water on top of that. And they're very minute changes. So if you're sitting next to the buoy, which is really the communications hub of that system, if you're sitting there on a boat and a tsunami passed you by, chances are you wouldn't even know it, right? It would be very, very, very small. And we have special software here at the Tsunami Warning Centers that can discreetly understand what that signal is, make sure it's not a swell or a wind wave, and pull that into our forecasting system. You're not going to see that type of wave signal show up on the National Data Buoy Center plot there, including the one that you're showing on the screen there. But what you can see, and I believe what you're looking at with that little red marker, the Rayleigh wave. Oh, that's okay. The Rayleigh wave, that's a seismic signal passing through, and due to that system actually shaking on the bottom of the ocean.
Right. Let me go back to that then. And here's just there's a really good Substack being maintained by two geologists, Judith Hubbard and Kyle Bradley, called Earthquake Insights, and they had pulled up this map of the dynamics around that particular fault, which it's busy. And one thing I learned in covering earthquake preparedness is states, regions that have a lot of low-level activity, people tend to have more of a general awareness of the need to be prepared. It's places like up the coast. We'll talk about this in a couple of minutes, like Portland, Oregon, where the quake is a once every 300-year event. It's a little harder to have people really understand. And not even that in California. I think I wrote about this a long time ago. It was Long Beach earthquake and other they were bad, but they were not catastrophic, but they gave a signal to society that you need to have building codes and you need to be prepared. So I guess in a way it's good to have a lot of low level activity. I don't know if that does that fit in your experience?
Well, right. I mean, it's very easy to focus on the response for a tsunami alert after you just had one. But what I think is more often the case is that we go a very long time without any type of alert that refreshes that action that people need to maintain awareness of. And that is the complete tsunami challenge there, maybe globally, is that they are infrequent, rare, but can be highly impactful events, and maintaining the focus, awareness, and readiness for that event to end hopefully well for you is really hard to do. And that means we have to focus our attention on the between event time to keep people ready to go.
Right. And the great shakeout, which I've written about before, I assume in tsunami risk areas that includes a lot of activity and awareness building around tsunamis, not just drop and hold on and all that stuff.
Right. And that's a challenging message there, because the way that you handle earthquake safety in interior California or interior Alaska is very different than if you're managing that experience at the coast, right? So there's some caveats to that, and from our alert center's perspective, of course, yes, you need to be safe from the earthquake. That's the immediate action, but the very, very next action is get away from the coast.
Absolutely. And to know how to do that, and to know what your phone is buzzing about, or if you don't have a phone, to know to turn on the radio or the like. That equity issue is something I think significant. Not everyone has a phone, a smartphone.
It's true.
Although even in New York, there was this deadly flash flood in New York City several years ago after a hurricane had come up from Florida and dumped an enormous amount of rain. And I wrote about this at the time. People, their phones were buzzing and they literally didn't know what it meant or what to do about it.
Right.
which is so your role in all this, the public education part, is really important.
And it's a challenge because probably the easiest and more likely response we get from folks is, oh, tsunami hasn't happened here in 50 years. We're not going to get one. We had the same experience there in the Midwest with tornadoes. Now, we've never had a tornado in my town. I live next to a lake. Tornado can't cross the lake. Well, what do you know? Branson, Missouri got a tornado and it crossed the lake, right? It's just a matter of time. And if you're at the coast, a tsunami can strike where you are. Just understand what your hazard map looks like and figure out what your relation to that hazard is.
And I was on one of the NOAA, the PMEL website, and I saw, it was pretty, I didn't know that there had been this tsunami that was watched in just this August. I thought it's just worth playing this out in terms of, this is, again, sort of modeled using all the seismic data of how that earthquake underwater played out across the Pacific. And
yeah. This was an interesting event. You see the magnitude listed there at 7.1. It is very unusual to have an ocean crossing event from something that small. And I use that small with air quotes, I guess. It's not a small earthquake. But there were some secondary effects, I believe, with that one, including some underwater landslides that may have exacerbated that impact there. But yeah, this was a little unusual.
Yeah, well, and again, it's useful to know whether it's in high schools or somewhere to have some awareness of this dynamic in the Pacific Ocean, because that one in 1700 and off the coast of Oregon and et cetera did the same thing. It sent waves. I think if I remember correctly, the timing and everything on it is understood because of it was registered and recorded by Japanese historians. That shaking off the west coast of the United States was propagated significant tsunamis to Japan.
Right. And so it's a lot more expected or common, I guess, if you want to use that word for an uncommon event, to see an ocean crossing event in the upper 8s and 9s, of course. So, think about the Great Alaska Earthquake, 9.2, of course, that traveled the ocean, right?
Amazing. So do you have a particular part of your brain that you keep in reserve for when the big one happens? And it's the when word that's kind of disturbing for people. This is not an if.
No, I think you have to. And I don't know that I understood that when I took this job, to be fair. But yes, there has to be a partition of your brain set aside for it. It could happen. It could be happening right now. And in just a matter of moments, we'll get the signal that puts everything back into motion again. I go to sleep like that. I have my bag next to the door prepared for that. And I try and keep my car gassed up in case I got to come in, right? That's the nature of this job. It's exhilarating in some ways and it's draining in others, but it's why we're here.
Yeah. One thing, I was talking with Roger Billam actually emailing about the quake, and he's actually out in the field collecting data along the San Andreas Fault somewhere. But he noted this dynamic with this particular fault can ultimately, he said the conversation that seismologists will be having in the coming days is how this might have added pressures to the Cascadia Fault up the coast. And I looked at this. This is a long-term average velocities map from that region. So I guess, the idea of foreshocks and the predictive value of something as a foreshock is still deeply uncertain, but it sounds like a good time to pay attention again to the Cascadia Fault.
Yes.
I'll be talking to Roger more about that. And this is the simulation that was done for that by NOAA et al. For that 1700 earthquake. And it's just such a reminder. You see the heights are the red, obviously, is the highest heights of the wave. I'll just play the animated version of this too.
Yeah, so as we're looking at this, I'll decipher the legend a little bit there. You're seeing the legend in feet on the left and in meters on the right. A 1 meter or 3 foot wave is our warning level criteria, the low end of a warning level event for us. And basically, what is a warning? It means we expect dry things to get wet in town. That it's probably not going to look like a Hollywood wave. That would be weird,
Right.
but it is going to look like a tremendous ocean surge that just keeps coming. And again, that's the lower end threshold for that. It can go a lot higher, of course. The lower end below that in the yellow zone is an advisory level event. So that basically means we're not expecting significant inundation or that push from the ocean to come into dry land, but we are going to see some coastal impacts on the beach and the bays and harbors there. And that's certainly capable of creating significant marine transportation, communication disruptions there. And it's still going to be equally hard to recover from just an advisory. And so I would couch that as kind of a marine warning level event, something that could seriously disrupt U.S. West Coast commerce and many of our strategic national ports there. So, that there was a significant event. If that repeats, that's a big deal.
It sure is. So any last, like when you run into a neighbor, or you're on the local TV show like you were a couple times, what's your main way of speaking to folks about how to think about a false alarm, quote unquote, or it's not a false alarm, right? It's tell us about the
and it wasn't in this case.
False alarm.
Really good point. And that is something that I've kind of taken on is my interest since I've been here is we need to do a better job. That's on us to do a better job about letting you know that an event did occur. So far since I've been here, I don't think we've had a false alarm, which is great. We never want that. And we know the impacts of having such a thing. In this case, this was a real alarm for a real event. And we did measure a tsunami in Arena Cove. The first wave was about 5 centimeters and the next was 9 centimeters. And you're saying, oh, wow, big deal, right? It is a big deal. There was a planetary event that moved a planetary amount of water, and thankfully it was not impactful this time. But that was the reason the warning was sent, because it could have been larger than that. Right. But it's on us to get that message out there immediately after the event. It's like, yes, we have measured water here, here, and here, and it was this. Because if not, then the perception is there that this is a false alarm. There's no reason for us to disrupt your lives with that level of notice. And I completely understand that we never want to do that. So getting back to those event reports, whether they're preliminary or not, and then solidifying that information for you and everybody else to see and use is really critical, because I think that helps solidify the fact that coastal California is in tsunami country, as well as Alaska and British Columbia and Oregon, Washington. Right. And we have to prepare and think like that between events to keep us all safe.
Yeah. One last thing, I'd have to look back at that initial warning. When they are issued, is there also an explanation of the delay factor? In this case, we know there could be a landslide that will happen. That's why we can't. That's why you should. I don't know. Maybe that's too much information. But how do you? Is there a way to sort of characterize ahead of time? There may very well be a delay in understanding.
No, I think you're spot on there. Yeah. To me, what you're describing is the need for us to lead our service partners along in the process and do a better job with that. So if we are at stage 1, how are we going to get to stage 2? Or is that 2.5? Where are we going on a roadmap of the event? Most events are going to play out in a very similar fashion. They're not scripted, because every earthquake's different and every location receiving that impact is going to be different because of the bathymetry and the coastal orientation. But we're looking for the same things every time to confirm or deny the existence of a tsunami. So after the first message, we can say, okay, the next step is we're looking for this, this, and this in these places. And if we get these answers, these are the next steps we're going to take beyond that, and start bringing people along with us as we go in that decision-making process and being explicit about saying those things. And that, I think, builds confidence. It builds surety in what we're doing and how we're doing it and what we're looking for, and helps bring everybody along for a better result. And some of that's messaging changes in our official statements. Some of that's just the behind the scenes partner coordination, but there's certainly opportunities there that we can do a better job. And I think that will take us to the next level of service.
Yeah. And builds fluency ahead of time. So people, like even broadcasters, aren't scrambling to know how to convey something.
That's right.
Good. Well, it's been great to have you in this pop-up Sustain What conversation, and people can find you pretty easily Googling, etc. And the information at tsunami.gov, of course, is all there for the taking. This is Dave Snider from the Tsunami Warning Center, the National Tsunami Warning Center, up in Alaska in the snow and dark, while I'm in Maine in the fading afternoon sunlight almost. And thanks for being on Sustain What, Dave.
Thanks a lot, Andy.
Okay, so that was recorded, and
Cool.
I can tweak it here and there, but that was very useful. And I'll let you know when it's webcasting.
Wonderful. Certainly appreciate it.
I appreciate your time.
All
right.
Well, let me know if there's if you have any other follow-up questions or things like that. Let me know, and I'll try and keep an eye on the email for you.
Great. Have you ever interacted with Yumei Wang in Oregon?
The name sounds familiar, but I don't think so.
I'm not sure if she was their geohazards lead for Oregon. And I had some great interviews with her a long time ago, including I'm sitting in a building in downtown Portland with her, and she says, "Oh, this is URM, unreinforced masonry." So we're toast if it hits right now. And it's like, "Oh, thanks for telling me." She's amazing. All right, well, thanks again.
Wonderful.
And I'll let you know when this